Okay, a very good afternoon, everyone, and welcome to this afternoon's session. Apologies, the Zoom session kicked me out and along with everybody else at the start. So can I just check the live transcription is working? Can somebody confirm that's all working okay? Anybody?
I'm not seeing anything, Dan.
You're not
No,
seeing
I
anything?
can't.
Okay, let me stop. It's slightly annoying. I have to stop sharing to do this. I was worried that this would happen. I think it's there we go. Let me re-enable it. It's obviously reset it, and I think it's reset all the breakout rooms. Yes, it has. Okay, joy. That's excellent. Okay, so when we come on to the breakout room stuff, you'll have to just give me 2 minutes just to set up the breakout room. So apologies for that. Let me also enable screen sharing because I'm guessing that's reset. Yes, it has. Okay, joy. I see Zoom's being its usual self. Okay, so I think that should be everything enabled apart from the breakout rooms, which I will do in a moment. Let me share my screen again. Okay, so that should all be working all right now. Brilliant. Sorry about that. I was suddenly conscious that in kicking us all out, but then apparently carrying on the meeting, they may have just reset everything, which it had. So this afternoon, this is going to be the second of the sessions in machine learning, and possibly the most important, I would argue. Something we're very conscious of in obviously the last session, in the first session of the machine learning module, we talked about all the wonderful things that machine learning can do, and it really is wonderful. I think there's so much potential for machine learning. I fully expect to see lots of project proposals coming in about using machine learning. I think that'll be absolutely fantastic. There's a lot of potential for its use and to really help people and have a real positive impact on people's lives. But it would be unfair, not to mention irresponsible, for us not to also talk about some of the darker side around AI, particularly if we're going to be sending you out there with all these new skills to be able to build very, very powerful new models using AI, then it's fundamentally important that before we show you that, you're aware of some of the risks of what this stuff can do and the very real impact this stuff can have on people's lives. And so this afternoon session is going to be a little bit different in that I'm not going to be doing a lot of talking at all. I want you to be talking primarily in your groups and then also feeding back to the main groups. There's going to be lots of group discussion going on this afternoon. And my principal role is really to give you some things to think about and then set you off to talk about those things. So I just want to sort of flag that up, that it's a little bit different. So you don't need any sort of technical skills. You get a bit of an afternoon off from the high technical stuff, but this stuff is incredibly important. And I hope by the end of this session, you'll see why this is so important. And I'd also like you to, as you're going forward, I mean, it's very much machine learning week here in HSMA. Obviously, tomorrow and Thursday, we've got the other two machine learning sessions where we'll be showing you how to do all this fancy stuff, and you'll be able to do it. So I want the kind of what we talk about this afternoon, I want that to be sort of ringing in your ears whenever you're learning about how to develop this stuff. And if you're going on either in your projects or elsewhere to develop these models, the stuff that we talk about today should always be at the forefront of your mind, because it's really, really important stuff. So with that in mind, I'm also going to put a bit of a health warning on this session, because the nature of talking about when AI goes wrong, and a lot of this, potentially can apply to some of the other wider modeling stuff you're doing, but particularly with AI. I'm going to be presenting some stuff that some of you may find offensive and or shocking. And I apologize if you are offended by anything here. I can simply say that it's not our intention to offend you. Unfortunately, I kind of need to show you some pretty unpleasant stuff so you can see the real world consequences that this stuff can have. This exactly the sort of thing that you're going to have the skills to be able to develop, and the real world impact that this can usually unknowingly have on on people's lives. And so I want you to expose to that. And the purpose of this session is to shock you a little bit, but to get you thinking, and then hopefully by the end of the session, thinking about ways in which you can avoid this kind of thing, or at the very least, put in mitigation measures to try and minimize any negative impact that it might be. And as I say, as people who are teaching you AI, it is our duty to ensure that you go into the world equipped with not only those skills to be able to do this, but also a really important understanding of what can go wrong and how this can have a very real impact for people. So I just wanted to put that up, and I apologize, as I say, if anything is offensive. In a way, it should be, because as I say, we're going to be talking about and showing you some pretty unpleasant stuff, but this is all real world stuff that has happened, and asking you to really think about the impact that the sort of things you're going to do will have for people. It kind of reminds me a little bit when I did my undergrad degree in computer science. We were taught how to hack. And the reason for that was so that we could essentially go off and make sure that we could protect against that kind of thing happening. But sometimes you have to sort of show people the kind of the dark side, the unpleasant side, in order to make something positive happen. I'd also like to give a really big thank you to my colleague Mike, who basically wrote most of the content for this session. Mike is a big advocate, as am I, of ethics in AI, and a big proponent of what can thinking about the sort of things that can go wrong. And Mike will be very happy to talk to any of you if you have sort of concerns and want to think about some of the considerations that you're making whenever you're developing this kind of stuff. But massive thank you to Mike. I'm almost totally basically delivering this session on his behalf. So let's begin. So Mike's entitled this session the alignment problem: how can machines learn human values? Mike also recommends these two particular books. Shamefully, I've not read either of them, although I'm determined that once I get a chance, maybe over Christmas, I'm going to have a read, particularly this second one, Hello World by Hannah Fry. Mike does strongly recommend this one in particular. It's a very easy read. There's nothing sort of heavy or technical. It's a very easy to read, but a very important book in terms of thinking through some of the stuff that you should be thinking about when you're developing AI models. They're both available as well as audiobooks. We've got Hello World by Hannah Fry and Alignment Problem by Brian Christian. And most of the examples actually in this lecture are taken from those two books. So what we're going to be talking about this afternoon, bit of an introduction, then we're going to be talking about the issues of representation, thinking about our data sets and questioning whether the data that we use to train our AI models are fit for purpose. Thinking about issues of transparency. Do we really understand why our models are making certain predictions? Thinking about some of the consequences and having a look at some of the very serious consequences of things when they go wrong, when our AI models don't do as we would expect. And I think there's very often it's very easy to think about some of the more obvious things in AI where going wrong, like accidentally not your algorithm not predicting that somebody has cancer, for example, when they do. But there's other much more wide-ranging stuff that maybe isn't so obvious, but which has an equally big impact for people. And then we'll summarize at the end. And all of this is going to be peppered throughout with lots of discussion. So I'm going to start off with a quote from Brian Christian, which I think sums up why this is so important. He says that there's a growing sense that more and more of the world is being turned over in one way or another to mathematical and computer models. It is as if we are consumed by the task of putting the world, both figuratively and literally, on autopilot. And I think that's a very important thing that we can all relate to and we can all see is something that's happening. It brings with it many benefits, but of course brings with it many side effects as well, and many of those are potentially quite negative for people. So it's very important that we consider those things. And so that's very much the context for what we're exploring today. Okay, so we're going to start off, I said I wasn't going to be talking much, we're going to start off with a bit of a group discussion. So you're going to go into your groups for the next 25 minutes. And I want you, first of all, to think about what could possibly go wrong with this headlong rush that we have globally in terms of putting everything into AI. AI has very much been held up as a panacea, the thing that will solve everything, particularly in the NHS. We've seen in recent times, it's very much being pushed as a thing that will solve all our problems. And in many cases, it may well have some fantastic benefits. But I want to use a group to be thinking about what are some of the problems. So I'm going to give you 25 minutes to have a bit of a chat about that. And then when we come back, I'm going to ask a few of the groups to share some of the things that you've been talking about. Okay, so we're going to start off. Of course, the first thing I'm going to have to do, though, is set up the breakout room. So apologies. Give me about 60 seconds and I will do that for you. Hi, everyone. Okay, so managed to bounce around a few of the groups there. Had some really good ideas being brought up. So I'm just going to pick on a few groups initially. You're probably all going to have a chance to be picked on this afternoon at some point because there's going to be lots of opportunity to feedback. But I will, as ever, spin the wheel so that we can see who goes first. Let's bring up the wheel and I will randomize it a few times because I'm still not sure how random this thing is. So we'll take my clicking to be part of the randomness and then we'll click and see who's up first.
Hey. Was it okay?
Okay, we got Deep Thought is up first. Have we got somebody from Deep Thought?
Sorry, Andy's really keen to talk, but
yes,
I've made a few notes.
Oh, private driveway to
so I'll just, I don't know if you can hear us. I'll just need to, there we go. Okay, great. Thanks. If you can all just check you're muted unless you're due to speak as well. Brilliant. Thank you. Sorry, Richard. God.
And you're showing us up. It's not good, is it? Anyway, so there are a few things we talked about. One was the issue of a redistribution of funds, because if you're going to, if AI becomes a pet project in healthcare, there's always a risk that you will put millions in, which is millions that could be spent on other areas of the healthcare system, for example. There's also practical issues about explainability of models, because even if actually it's a really good model, generalizable, reliable, you know, if it is just, I painted the kind of slightly flippant analogy of you walk into a consulting room and there's a little black box, you push the button and the consultant tells you, oh, it's good news, you haven't got cancer. You know, I think how trustworthy they are, how much you believe them, how much you could defend a decision, you know, if one's made using some of these methods. There's also a good point actually about the data, both data that goes into models, data comes out of models, and actually who owns it and who controls it, and what kind of protection are there for those who perhaps share their data for a completely different purpose, plus or minus being aware of this is how it might be repurposed. Then we had some of the practical issues about in terms of use in the NHS, and the fact that actually in many cases this would probably require quite significant investment both in hardware, software and people to be able to conduct this analysis and actually true to know when they're appropriate and actually how to interpret the results that they get. There are other things around the dangers of perhaps using AI methods in isolation rather than perhaps part of a kind of a wide, you know, to support decisions, you know, as part of a wider strategy. And then the final point I wrote down was around if you have biased data, you get biased results, and that's not necessarily exclusively an AI problem, but definitely can lead to a spot or bother.
Brilliant, thank you. No, they're really, really good points that you've raised there. Interesting, your last point. We're going to talk a little bit about that this afternoon, but some really good considerations of some of the wider stuff there. So no, really, really good, really good. Thank you. Okay, let's pick on another group. Spin the wheel again. Who have we got next? Was it going to go over? Yeah, it is. It's going to be Talkie Toaster.
So we had a couple of similar areas. So we talked about data ownership or rights implications, risks of security failures, which could in itself lead to loss of trust or introduction of fear in the users of any given service where it's applied. We talked about risks of bias, either in the model or the data fed to it, or both. We talked about various elements of error, and the risk of that self-perpetuating. So it could self-perpetuate real-life bias or judgments, for example, or introduce false negatives or positives, which I think is similar to the previous group. We talked about, it got a bit dystopian, but loss of jobs and economic impacts as a result. So, you know, when this is applied at scale, what's the impact as a sort of on the broader economic side of things? We also touched on accountability. So in a sort of today's, you know, if a clinical decision is made by one clinician, the accountability of that decision is clear. Whereas if a decision is produced by a program that's been contributed to by multiple people, and it produces a decision, who's accountable if that's the wrong decision? We talked about as well, we touched on the black box idea. So sort of an understanding of that. So the purchasers of and the users of those black boxes might have not as much detailed knowledge of how it's working. So we're sort of putting faith into something which, if we don't understand the sort of the mechanics of it, is that a risk? But we had a few other points. I'm conscious I'm probably rattling. Am I right just to finish those off, Dan, or do you want me to?
Yeah, no, carry on. Yeah, that's fine.
So we touched on reliability. So the point at which an AI is more reliable than a manual task, does it take over that industry or that area of skill? And then that touched on reliance. So if you rely on it, then as a result, then could that be a folly when things go wrong, because you might have lost the sort of human skill to advance it, which then led to a discussion point around innovation. So if you are replicating a skill or a decision process, however complicated that may be, that might replicate it. Whether or not it could innovate and advance upon it might still need human input. So it's sort of, we didn't really go down that path, but we sort of touched on it briefly. And we touched on some softer sides as well. So we talked about less possible risks, so around lack of human interaction. So if everything becomes an AI, then actually, you know, do you lose a human element of your engagement with the world in various different avenues? And actually, as a sort of from a user perspective, where it's poorly executed, so you might have a poor customer experience, you might lose customers from a customer retention point of view if it's poorly executed. And then lastly, we touched on accessibility. So there could be a risk that it exacerbates inaccessibility issues that currently exist, and to what extent is accessibility, you know, front and center as an area of focus for this in any sector, you know, not just public sector work.
Brilliant, thank you. No, that was really good. I think a really nice wide range of considerations that you've made there, which is really nice to see, and particularly around the sort of black box stuff. I mean, that's something that you'll, it's a really interesting point, because when we come on to show you neural networks in particular on Thursday, one of the great ironies of neural networks is that, one of the reasons they were created in the first place was to try and better understand the human brain, and actually they've become very black box. So they've turned out to be amazing, powerful predictors, but nobody quite really understands why. And it's very difficult. They have become black box in the sense that you will get very accurate predictions from them for a wide range of settings, but you won't really be able to explain why that is. And you won't really be able to explain, in a lot of cases, you know, where those predictions are coming from, why it's made that prediction over that prediction. There are things that you can do in terms of using things like Shapley values, which we'll talk a little bit about. In fact, I mentioned them a little bit today. But there are issues with that, and so I think it's really, really important point, particularly when we're considering the ethical side of things. Brilliant, thank you very much. Okay, let's press on. So really good discussions, thinking about some of the potential issues in our sort of thirst as a global population for AI. So let's talk a little bit about, and I heard a few of the groups talk a little bit about representation and our data sets and whether there's sort of bias in our data. So let's think about our data sets and question whether the data sets, those data sets that we are using to train AI, are they fit for purpose? So some of you may remember this horrible story from, I think it's 2015, so 6 years ago now, where we had a story of, and probably most of you are familiar with, if you've got a phone. You've got Google Photos, an Android phone. I mean, Apple does a similar kind of thing, that it'll automatically try and use image recognition to basically try and bundle similar images together and try and do that intelligently. Something you would imagine would be sort of fairly harmless, a bit of a nice thing, a nice user-friendly thing that you can do that makes users feel good about their new phone and all those features. Well, in 2015, on a Sunday evening, Jackie Alsonay got a notification that a friend had uploaded a photo to Google Photos. It created a new group for it, and it had placed that photo in the new group, and the group was titled Gorillas. Now, put yourself in the mindset of her and her friend. When you see what on your phone you just assume to be, and you may not even be aware that there's an AI algorithm going on behind that. Now put yourself in their position of seeing that, and the horrible situation of seeing that. Now, I don't think anybody is saying, first of all, that Google were deliberately doing this. Absolutely not. And I think it's fair to say they were quite rightly equally appalled as everybody else was by this. They did incidentally fix this after, although I'll come back to how they fixed that, and I use inverted commas very much a little later. But it just goes to show, I really want to point this out, that this is something that if you were building an AI that did some image recognition to automatically categorize photos on your phone, you may not be thinking about some of the ethical implications and some of the things that could go wrong if you were to do that, because you wouldn't necessarily think that there would be anything that could potentially go wrong that would cause an issue. But this is a really good example of exactly the sort of thing that can go wrong that you may not have even considered. And AI has just done that to someone. Okay, so just let that sink in a moment. Another example here. When Joy Bulamvini was a computer science undergrad at Georgia Tech in the early 2010s, she did a lot of work looking at trying to recognize emotions in faces, using facial recognition to try and identify emotion, so using AI. The problem was that she found the library she was using to train her model would not detect her face until she held up a white mask in front of her face. And at the time, many of the libraries were trained on what's known the labeled faces in the wild database, big database that can be used as many are today. You have these big databases that are used to train these AI algorithms. And it turned out in that database, there were twice as many images of George W. Bush in the whole data set as there were of all Black women combined. So as we try and understand what's happening here, this goes back to an earlier point that I heard in one of the groups. Is there a danger that what we're doing, if there's inherent bias that we're seeing in the real world and in real data, are we just in danger of using AI and amplifying that? And that's something we're going to come back to. Another similar point here. Also research by Joel Bulamvini and Timnit Gebru, who showed that the error rate of gender recognition, so using image recognition to try and automatically identify gender, was 100 times higher. The error rate was 100 times higher for dark-skinned women than white men. Okay, and again, it goes back to this point. All of that data that was used to train these models out in the wild, there's inherent bias in it. There's poor representation of certain minority groups, and so if you're then trying to build an AI that's based on that data, then all it's going to do is learn those same kind of biases. So we have to be really careful just in terms of the thinking about the data that we plug in to an AI. There's also potential issues as well around some of the stuff we do with words. So obviously in the natural language processing module, I'll talk a lot about using AI for words and how we can use those kind of methods that we're teaching here and in the machine learning module to be able to do fantastic things in terms of identifying the sentiment of a piece of text or extracting named entities and all that kind of fascinating stuff that's really, really useful. There's also something in natural language processing known as word embeddings, and we'll touch on them a little bit during the course, which is basically where fundamentally, whenever you're plugging words into a computer, computers operate at a fundamental level on numbers. So you need some way in which to convert them into numbers. There are various different types of what's called word embeddings. Word2vec is a big popular one that's used, which is a way of encoding words as numbers, and then encode words in space so that you have similar words located closer together. So words that are semantically similar will be located closer together and clustered. It also picks up any relationships that exist between words, and it allows you to do all this fascinating stuff, like you can add words together or you can subtract words. So for example, subtracting the word embedding vector for male from the word king and adding the word vector for female gives queen. So you can literally do king minus male plus female equals queen, and you do that on the vectors that are the sort of word embeddings for these words. And it's because of the way in which they've been set up so that it identifies similar words and the relationships between words. Brilliant, fascinating. But these word embeddings have learned these kinds of relationships that give it this kind of power from human text, from stuff that's out there that people have written, from everything that's on the internet that's been put up in various corpuses. So a little side effect of this is that, for example, if you were to subtract the word embedding vector for male from doctor, so if you said doctor minus male plus female, it'll give you the word nurse. Now, clearly, that's a very sexist thing to do, but it's not the AI that's done that. It's learnt this from the sorts of things that it's read, that it's essentially learned from the text that it sees that's out there in the wild. Now, word embedding models are used very extensively, and in a lot of things you wouldn't even realize these things are being used in. So things like internet searches, in how it ranks various search results. Things like translation, how we automatically translate between different languages. Things like sentiment analysis, which you're going to learn about in this course, where you can identify the tone in a particular piece of text. And this kind of stuff is used routinely, and you'll be using models that have been trained, these big models that have been trained on these big corpuses that contain all of these biases within them. So based on what we've just talked about, and based on this stuff around word embedding in particular, I want you to go back into your groups, and I want you to have another chat, and I want you to think about what are some of the problems you think could arise from these kinds of biases in word embeddings, bearing in mind some of the things that we've just talked about in terms of, not being aware that some of this stuff, which may seem perfectly harmless on the surface, can actually have really negative consequences for people. So I wanted to have a bit of a chat about that, and then for the next 20-25 minutes, taking a 10-minute break there as well. And then when you come back, I'll ask a few of the groups to feedback. So if we say we'll come back in about half an hour, let's come back at 5 to 3. So just take a break after your chat as well. And I'd love to hear what you've been talking about. Okay, let's stop there, and I'll let you talk in your groups. Okay, everyone, welcome back. Hopefully you managed to get a little bit of a break there too. So again, managed to bounce around a couple of the groups, heard some interesting chats around some of this stuff. So I'm going to pick on another couple of groups just to feedback on some of the things you talked about. So let me share my screen and bring up the wheel. Okay, I'll shuffle it a few more times and let's spin it. Yeah, it's going to be Hal. It's Hal 9000.
Hi. So we were thinking around a few different issues. One was thinking about evolving language and how that could be confusing for the issue of word embedding. For instance, the changing of the meaning of words like wicked or sick, for instance, changing from older usage to more recent usage. Also, whether there could be confusion caused by ironically intended material being used to develop associations. And also thinking about internet searching, we were thinking about product associations, and again, like we've been discussing previously, perhaps prejudice within the data, leading to sort of compounding of associations, which may be prejudiced. An example that I suggested was maybe around parenting and women perhaps being closely associated in perhaps an inappropriate way. And we talked about issues around whether it's word embedding, but to do with selections. We're trying to think about internet searching again, and thinking about YouTube in particular, and how you can go down a particular cul-de-sac in terms of your selections that might be self-perpetuating because of the nature of how the system pushes you back towards the things that you like, and that can self-perpetuate embedded associations. And we're thinking about in translation how cultural associations might differ between cultures, and that could cause issues around word embedding as well.
Brilliant, thank you. No, that really good points there, I think. And I heard a number of groups talk about the things like evolution of language. I think that's a really important point. And you're right. I mean, in terms of the sort of the consuming the biases out there. I mean, I mentioned it to a couple of groups that I sort of jumped in on, and I mean, the key thing to think about here. I mean, this is one way to think about how problematic this could be. So if you think about these kind of word embeddings and the natural language models that are being trained on, basically, in most cases, the big models that the big companies are using still use this model of we train up our models by basically chucking everything at it. So we send the models out and we let them consume everything. Now, if you think about what that's doing, essentially you've got models that are consuming these vast quantities of information, including stuff, from not just news reports, which may have their own biases within them, social media posts, somebody said, comments on YouTube, and that's the kind of thing that this is consuming and learning from. And of course, any machine learning model is not it learns to that it's correct more when it gets things right, and it sees things more, and it is able to predict those kinds of things more. So if it sees prejudice out there, and it's consuming that, and it sees clusters of that, and it's able to pick up on that stuff and learn it, then it's not learning that that's not right. It's learning quite the opposite, that it is right, and that's how it should be making decisions based on that kind of thing. And so that's quite a scary thought, I think. If you were to think about imagining teaching a child and said, here you go, here's all of the information that's been written on the internet, go and consume it, and that will teach you everything you need to know. Would that really be the way in which we'd want to teach a human? But yet that's what we're doing with machines, and so I think that's quite a stark thing to think about. Thank you. That was really good point you raised there. Okay, let's spin the wheel again. Looks like it's going to be Skynet. Yep, Skynet is next up.
So we also talked about words changing meaning and how you'd represent irony or phrasal words. We also talked about limited data sets that you could use for that purpose, and they would probably be dominated by things influenced by the media, so films, particularly US markets, and mostly white attractive young people inputting, and then how that would reinforce bias. And then we got a bit sidetracked, and we sort of talked about how you would rectify it, and that by excluding parts from the data set, wouldn't you be biasing itself? And if by the nature of the data set it's so big, how would you decide what to take out? And that in some ways the AI is actually highlighting the bias in the data set, and can kind of tell you something you didn't know was maybe there. But then we talked about designing selection of different data sources to represent populations, so limiting or capping the number of sources from particular areas or remits. I think that was about it. I don't know if anyone else wants to add anything.
That was good. I think some really good points you raised there, and a really interesting point you made there about bias and how you go about trying to limit that, and are the potential issues in making us as also biased humans making decisions about what should and shouldn't be included. And so I think there's and there are potential dangers with that as well. And so I really liked that point you made about, can we use AI to kind of expose some of this stuff? I think that's quite a nice way to look at that. And you could almost imagine, you know, you sort of first step for your AI in being able to expose some of this stuff, not only to demonstrate how you might get around it and how you might need to think about moving forward. Is that really what you want your AI to be doing? How do we ensure that it's not doing that kind of thing? But also giving people a bit of exposure into not just blanketly sort of blindly trusting the AI that's just been, you know, sort of trained on everything and assuming that will be okay. So I think that's a really nice way to think about it. Brilliant, thank you. Really good points. Okay, let's move on. The next few things to talk about. So we've talked about representation, about how representative our data is. So what can we learn from all of this? As with any machine learning, your model is only as good, and in fact any model really, your model is only as good as the data you feed into it. And I think that becomes even more stark when we're thinking about machine learning models. The performance of your model is going to be dependent on having sufficient representation of your examples in the data set. You need to make sure you're getting sufficient representation for everybody that is represented. You should think about testing your models and testing your model performance on subgroups, particularly where you know that there are particularly sensitive groups, where things like protected characteristics like gender and race are present, particularly where you've got situations like that. You should be testing your performance not just as a whole, but also looking at those subgroups. How, you know, what are we performing well for these particular groups, for example? And a key message, I guess, and the reason why we're kind of shoving this down your throat a little bit, and I'm not going to apologize for that, because I think this is really important. If you're building these models, it's your responsibility. The buck stops with you. As the model builder, you are responsible for the data that you are using to build and train your model. So at the very least, what you should be doing is identifying and communicating and making sure people understand any key weaknesses that you may have in that model, that it may be poor at making predictions for a particular minority group, for example. But what's even better is to try and fix those problems, trying to gather more balanced data or reducing your overrepresented data. And there's things that we can show you in the course that allow you to do stuff like that. And, you know, we talk about potential issues where you've got one group that is particularly dominant in a data set. I mean, you get this kind of stuff in less sinister ways, in terms of, you know, things like patient feedback. If you're trying to train a model to identify sentiment in patient feedback, most people tend to put, usually in things like the NHS, tend to write very positive things generally, because they're usually quite appreciative for the care they've got. So you'll find when you look at that kind of stuff, you'll be dominated by people that are talking quite positively. But the problem with doing stuff like that is that you're then introducing a bias into your model, because you're training it that actually it's okay most of the time. But actually what you may be really interested in is when it's not okay, and trying to do something about that. And so it's the same issue, that you're trying to better balance your data. Okay, so let's think a little bit more about, we've talked about representation. Let's think a little bit now about transparency. And we heard a few of the groups mentioning this earlier, about trying to understand why our models make certain predictions. And one key thing to remember, and as analysts, you're probably very familiar with this, but it's worth drumming in again, that correlation is not causation. And really trying to understand, particularly with as you're developing AI models, this can become quite pertinent. So in the mid-90s, there was a group of researchers led by Tom Mitchell that produced state-of-the-art neural models for predicting the risk of death from pneumonia. And basically, they were going to use this in order to try and automatically select, use AI selection to try and predict which patients should be given more intensive care. And what they were surprised to find was that the algorithm essentially said that those who had a history of asthma had a lower risk of death, and so they were deprioritized for selection for more intensive care. And that's quite counterintuitive. You wouldn't kind of expect that. But what they found by talking with the clinicians is that actually asthma patients have a lower risk of mortality because they receive more intensive care, not because the pneumonia is less serious for them. But we've got to be very careful that we're not plugging in this data into our model and that it's learned that say, oh, well, your asthma patients are fine because their mortality seems much lower. Well, it's much lower because we're giving them more intensive care, and that's what we're building this model to try and identify who should get more intensive care. A similar example here. So in 2015, a couple of dermatologists, Justin Cohn, Robert Novoa, used a Google image analysis network. They trained it on 130,000 skin lesion images to recognize melanoma and other conditions. And there was a paper that they published in Nature 4 years ago, where they reported that it outperformed 25 dermatologists. That's amazing. Okay, really incredible machine learning stuff. And if you were presented with that, no wonder it ended up in Nature. This is a big deal. They've created something amazing. Then a year later, they had to issue a warning because they realized there was a problem with their system. What the system had done is it had learnt any images containing a ruler were more likely to be an image of something cancerous. So because the training images of these cancerous images had used rulers, it identified this ruler was the important thing in identifying whether something was cancerous or not. Now, we can see how that's happened. But remember, that paper got published in a massive journal. This was quite rightly, they thought they were onto something amazing with this. And actually, there was this fundamental problem. And so really understanding why your model is making the kinds of predictions that it is really important for this transparency and for understanding why it's making those decisions and the consequences of those decisions. Now, you can imagine if that was used in general practice, widely used, it would cause huge issues because, of course, you're not going to put a ruler next to someone if you think they're cancerous, in which case you don't need the machine learning model. So what can we do about that? And I mentioned earlier that there are these things called Shapley values. So Mike has done a lot of work along with Kerry around the use of Shapley values. They're potentially one solution that allows you to try and unpick your black box. If I said earlier, if you're building a neural network, they're very black box in nature. In that it's very difficult to understand why they're making certain decisions. But Shapley values are actually quite a nice way in which you can try and unpick that a little bit. And they can be used across all machine learning model types, including deep learning models. And basically what they do is they show the influence of your individual features. Remember, we talked about features in the first session of this module as being your kind of inputs, the things from which you are trying to predict your output, your label. And that in image recognition can include image pixels. They're your features in image recognition, your series of pixels. And the extent and direction, so not just what the individual features are, but the extent and direction of the influence of that feature. So in this example here, we can see red and blue bars of different lengths. So basically the red bars and the red pixels in this image above show that the these are factors that increase the model output value, and blue pixels or blue bars down here show factors that reduce the model output value. So remember, when you're building a model like this, essentially you're trying to output a number which will represent usually your probability of you thinking, is this cancerous or not cancerous, for example? Does this belong to this classification or not? And Shapley values allow you to see at a glance what are the things that are not only the most influential on making that decision, but what's the direction, what's the polarity of that that influence? Is this, if we see this, does that vastly increase the probability that is cancerous, for example, or at least what the model has learned to say this. So that allows us, if we use Shapley values for something like this, then we could identify, for example, that actually it's this thing down here that's causing the biggest influence in terms of determining the model determining whether something is cancerous or not, and therefore that kind of issue can then be avoided. So they're a really useful way to try and unpick why your model is making certain predictions. A, because that's useful information in itself, but B, to make sure it's not doing something really stupid. It's picked up on something that it didn't realize, or that you didn't consider was important and it shouldn't have picked up on, but something that is present maybe in examples where you've got this classification in the training. And it goes back to some of the issues around overfitting that we talked about last time, where it's, in this case, it's overfitted. It's picked up on this the presence of a ruler as being important in determining whether there's a cancer there. Okay, so again, armed with some of the information that we've just talked about and some of the things we've just thought about here, I now want you to spend the next group discussion discussing the following. Now, a lot of you will recognize this. It should look very familiar, unless you're one of the trainee mentors, and which is you'll never have seen this before in your life because we didn't ask this, but this was one of the questions that we asked all of you on the HSMA 4 application pack. And the reason was to just try and get some sense out of you about some of the potential ethical issues and thinking about how you might consider some of those things when you're building models. So as a reminder, this is the scenario: you work for a local police force. A local academic group has developed a piece of cutting-edge facial recognition software which is 90% accurate in automatically identifying patients turning up to a GP surgery to save them signing in at reception. They've tweaked the algorithm and they've run some extensive tests on the new software, and it's been shown to be 99% accurate at identifying sexual offenders. Your area has experienced a number of late-night sexual assaults taking place around a local train station, and your force is considering installing this software, which seems to be proven software, at the train station, such that any people flagged up by this piece of software as a sexual offender who are entering the station after 8 p.m. trigger a number of officers attending to question the subject's presence at the station. Typically, the station sees around 200 people attending between 8 p.m. and midnight. So we heard a lot of you, your thoughts individually in your applications on this thing, and there was a lot of different things that were being talked about in your applications. So I now want you, within your groups, to talk about what you think about the implementation of this system based on what you now know in terms of machine learning and what we talked about last time, and also some of the ethical issues that we've talked about so far today. So I will reopen the groups and I'll bring you back in about 20-25 minutes and ask a couple of groups to share their thoughts. Hi everyone. Okay, so welcome back. Again, heard some interesting discussions about some of this. It's interesting to see you discussing this. Obviously, we'd seen your sort of individual responses in your application, so it's interesting to hear you talk about some of the issues around the potential implementation of this fictitious system. So I'm going to pick up on another couple of groups. Let me share my screen. Okay, and let's spin the wheel. So it looks like, yeah, it's going to be Robocop. So someone from Robocop, if you'd like to just give us a bit of a brief overview, what you talked about.
We sort of started by saying, obviously, with anything with facial recognition, I think as we've discussed today anyway, there's quite a lot of issues around existing software to do with race. So you might find that you were accidentally profiling, even if it is supposedly 99% accurate, that within that 1%, it might be specifically discriminating more against people of certain characteristics, potentially darker skin. Seems to be a common issue with sort of AI recognition. We did also wonder whether it actually is 99% accurate, which sort of comes back to what we were just covering in the lecture about depending on how it's been trained and tested. So if you're training it on sort of mugshots of people against just, you know, ordinary people out and about, has it been picking up on the fact that these are mugshots instead of actually doing a good job of recognizing people, in which case, is it really 99% accurate, or picking up on expressions or something like that? We then had sort of other concerns about sort of relying on the system, so that if you've got police turning up, you know, every now and then on the basis that there's a sex offender there, is the sex offender just going to start going elsewhere? In which case, the crime's just going to move. Which I think sort of something that you see quite a lot in real life, that if you target something in one area, it just moves somewhere else. People who aren't registered sex offenders and aren't already known to the police may slip through the net. If you're just basing it on a sort of database of people that you've already got. What else? And potentially in the case of someone who looks quite like someone who is on your database and is repeatedly being, well, harassed, I suppose, by the police, are they going to get quite defensive about that, which could lead to sort of an escalating situation where they don't want to comply with the police, and that sort of gets out of hand, which is sort of thing that you see quite a bit as well in situations where things get nasty with the police.
Brilliant. No, thank you. No, really good points you made there, and touched on some of the stuff we'll talk about in a moment, actually. But yeah, really important. And again, questioning that 99% accuracy. I think I deliberately didn't tell you much in that question. That was deliberate, particularly in light of some of the things we've been talking about in the last couple of sessions as well. And actually, but that's the kind of, it's the kind of information that, you know, if somebody's selling you an AI system, that's the kind of information that they probably give you. And so, you know, on the surface, something can seem very good and very effective, but we've already seen issues with potential accuracy. And what does accuracy mean, and all sorts of issues around that, and how it's been trained, as we talked about earlier, and is it picking up on particular groups, and why is it coming to those conclusions? So the issues of transparency that we talked about as well. So no, really good. Thank you. Picked up on a lot of issues there. Okay, let's spin the wheel again. I think it's going to be, it's going to be Max this time.
I think I've wanted to this one. I think, yeah, we have similar concerns still. I guess the questions about what they mean by accurate. Where's it failing? Is it failing on false positives? Is it failing on false negatives? How it sort of seems that there could be serious environmental differences in the detection. Was the original training set sort of straight on pictures of people's faces, and now they're trying to do it off sort of dodgy, poorly lit train station CCTV or something like that. If you have sort of committed a crime in the past, that's not just sort of justification for you being arrested at a train station. It's not illegal to get on a train. It feels like a situation where just better policing strategies to deal with this would be sort of better deployed. Do they even know, since it's around the station, do they even know that the offender is likely to be a passenger or is a passenger? Also, there's a general issue with sort of low conviction rates for sexual offenders. So unlikely that the person, you're unlikely to end up on the sort of sexual offenders register if you have committed a sexual offence. So yeah, lots of problems with it.
Yeah, no, absolutely, really good points again. And I think and a number of the groups I listened into talked a lot about some of the potential practical issues in this, and some of the legal issues indeed of doing something like this. So I think that's again stuff that I left a little bit fuzzy there. So just going back to this, so one of the key things to think about, and it's really good points that you've all raised there. One of the things I kind of wanted to get to really was, so we talked about this 99% accuracy, and clearly there may be potential issues with how it's been trained up, and is that actually a good reflection of how it performs in the real world? But even assuming it is, so let's park that for one moment. Let's imagine this thing is 99% accurate at being shown a face and saying 99 times out of 100, yes, they are a sexual offender, or no, they are not a sexual offender. And let's park the fact that about the practical concerns of doing this, or even the legal concerns around, well, maybe they are a sexual offender and they're just going to catch a train. There's nothing illegal about that. So there's all sorts of issues that a number of you have picked up on. But one of the things that I think is worth thinking about, so imagining that it is 99% accurate, let's just think about what that means. That means that 1% of the time it's wrong. So it'll classify someone as being a sexual offender when they're not, potentially. Which, if we've got 200 people coming through after 8 p.m, that potentially means that every night you could have 2 people who are wrongly identified as a sexual offender. And the consequences of that under the system are that they will have a group of officers coming down to question them quite publicly about why they're at the train station, and explaining that they've been identified as a potential sexual offender. 2 people a night, potentially, who are wrongly identified in this way. Now think about the consequences of that for that person. Think about not just in terms of, there's probably a growing mistrust in the police, in AI, quite rightly in these kinds of methods, but the impact for their lives in being questioned in such a public way, and all because a system that's right 99% of the time, unfortunately for them, they fell into the unlucky 1% where it was wrong. And so that's something to as we move into this this next bit, I think is worth remembering, as we talk a little bit about some of the consequences. And really, everything we've been talking about in this afternoon session boils down to this. It boils down to what are the consequences of getting this stuff wrong. We've explored the ways in which this stuff can go wrong. We've explored the ways in which biases, natural bias in the data that this stuff's being trained on, can lead to things going wrong. We've talked about models not being transparent, and therefore not really understanding why they're coming to certain predictions, and that leading to things going wrong. But we haven't talked about quite so much some of the consequences of this going wrong. And we already touched on a little earlier about in the example of the Google images and the black woman who's identified as a gorilla automatically by this AI. Now that's obviously had big consequences for her and for her friends, in something that most people wouldn't have automatically thought about that when building that kind of AI. Let's think about another example here. So I'm going to tell you about a little story about a man called Steve Talley. So Steve Talley was asleep at his home in South Denver in 2014 when he heard a knock at the door. He opened it to find a man apologizing for accidentally hitting his car. The stranger asked Talley to step outside and take a look, and he obliged. And as he crouched down to assess the damage to his driver's door, a flash grenade went off. 3 men dressed in black jackets and helmets appeared and knocked him to the ground. 1 man stood on his face. Another restrained his arms, while another started repeatedly hitting him with the butt of a gun. Talley's injuries would be extensive. By the end of the evening, he sustained nerve damage, blood clots, and a broken penis. I didn't even know you could break a penis, he later told a journalist. At one point, I was screaming for the police. It was then I realized these were cops who were beating me up. Why had this happened? Well, it turns out that Steve Talley had been misidentified as a bank robber and this bank robber had also assaulted a police officer in the course of one of the robberies by an AI face recognition system looking at CCTV footage. Now, just let that sink in for a moment. A perfectly innocent man receives this as he opens the door and receives life-changing injuries, not to mention the sort of psychological damage that this has done. Now, clearly, there are issues at play here around the way in which the police behaved, even if they had got the correct person. Absolutely not taking away from that. But let's not forget here the role that a piece of AI played in this happening. A piece of AI identified and said, that's the man. I'm confident that's the man who undertook these robberies and assaulted that police officer. And an AI did that. Okay. Now, just think about when you're building AI systems, the consequences of some of the stuff that you're doing. Now, you may say, well, the sort of stuff we'll be doing won't end in this. I'm sure the Google engineers, when they were building photo recognition, automatic photo classification systems, thought exactly the same thing. And particularly for the sectors that you're working in health and social care, obviously we can see quite clearly how the consequences of getting things wrong. But I would argue even more so in the domain of policing, where essentially you're making decisions or helping to support decision making that is really potentially going to hugely impact someone's life. And you need to bear that in mind whenever you're doing anything like this, about the potential consequences. What are the consequences when this thing is wrong? And remember, when we talked about AI, when we first introduced AI in the first session, we said these computers will get things wrong. They will absolutely get things wrong. You will not be building 100% accurate models. Things will go wrong. And you need to think about what the consequences will be when it does get things wrong. What's going to happen? What potentially could happen as a result of that? And there's a great quote here, that people make mistakes, but to automate mistakes and bias at scale takes automation. And it's something that a number of the groups touched on earlier when you were thinking about what could go wrong in the very first question, what could go wrong with AI. And it's a really important point in that we're in danger, if we're not very careful, of creating a future in which there are these fantastic AI models that are so beneficial in so many ways. But actually what they've also done is automated all the mistakes that we make as human beings, and all that bias and prejudice that's out there and within us as human beings. And we've automated that at scale to make it even more impactful negatively for people. So that tagline that I put at the start of the session, as I do for all of the sessions, that quote about not even knowing that you could break a penis, I kind of want that to stay with you. Think about that. Let that be a little reminder of the kind of ways in which this stuff can go wrong. Somebody building an AI system for automatically identifying criminals, you may think this is a great thing that we're doing, and that nothing could possibly go wrong with this, and this is just going to help reduce crime. Think about that example of what can happen when this stuff goes wrong. Think about the Google image recognition example. Put yourself in the position of that person. Think about what can happen when these things go wrong, even where you're building stuff that you don't even think will have that much of an impact on people's lives. So what I want you to do now for the final chat in your groups is I want you to, as a group, think of a use of machine learning or AI more generally within your area, your organizations, your sector, that could be really useful if it were to perform well. So think of a really, nice application you can imagine if they're using AI. Now, then I want you to think about all the ways in which it could possibly go wrong. Who could suffer as a result of this thing making the wrong judgment calls? And what might they suffer? And then think about how you'd ensure that you test for those unwanted consequences. How would you go about trying to test your model to make sure it wasn't doing those things? And how would you make sure that people that you're providing this model to, or providing the insights that this model generates to, how would you help them understand the possible weaknesses of that model as well as the strengths? So I'm going to give you about 20 minutes, so until 20 past 4, just over 20 minutes, and then I'll ask a couple of groups to share the thoughts when they come back. So all throughout this afternoon, we've talked about some of the problems, and I think now is a good time to think about, reflect on that in real world terms for some of the stuff that you guys might be doing, but then to think about what could you do about it? Because that's the key. That's the whole reason we're doing this, to get you to think about the problems that could occur and that will occur if you're not careful, but also thinking about how you might resolve some of these problems. Okay, so I'm going to open up the breakout rooms, have a chat in your groups, and I look forward to seeing what you've chatted about in about 20 minutes. Hi, everyone. Okay, so welcome back. I hope you managed to have some good discussions there on some potential areas. So I'm going to pick on the last 2 groups just to present, and then I've just got one more thing to talk about before we close very briefly. So let me just share my screen. Where are we? There. Right, let's shuffle them again once more, and let's spin the wheel. So 2 groups are going to get away with it today. Oh. Okay, looks like it's going to be Holly. Holly's up next.
No, so in our group, we started talking about how some of the decision making on a large scale might have unintended consequences. So using an example of the what happened in the Immensa testing back in September, October, where there's a lot of tests that were missed out. No one would have thought that actually just because you've got a number of tests not being done would have actually resulted in actual death. So a professor at Warwick University calculated that resulted in something like between 400 and 1,100 additional deaths, or things like when Public Health England had that error last summer over the Excel spreadsheet where 15,000 COVID cases were missed. That's estimated to resulted in 1,500 deaths. So it's almost like some mass automation of processes could actually have very long-reaching consequences, really. And then we were then saying how the example on this lecture earlier about skin cancer, for instance, is another good example of that, really. If the AI looked at the ruler to determine if there's going to be skin cancer, that could have meant that there's lots of examples where you lots of more severe cases missed, and later interventions which would have a knock-on effect on hospitals and its workforce, really. So then we started looking at how we might want to, what is the threshold for deciding whether intervention would be okay or not, or whether AI would be okay or not. And then we're looking at how most interventions would have some negative impact on people, but then there'll be ones with less of an effect on people where this might be more, some of the risks might be more acceptable. An example for that, which could be contested, would be things like self-driving cars. So they are, if implemented correctly, you could argue that they are on the whole safer drivers than any human could be, but then that could also introduce certain biases for some groups. For instance, people who can afford self-driving cars are likely to put everyone in the car, and the people who might be pedestrians walking by are more likely then to be hit by a car that does eventually make mistakes, resulting in certain biases being reflected, really. We then, I suppose one of the things that we ended with, actually, how do we start addressing some of this? So how do we addressing some of those biases against certain groups that could result? Can we then, let's say, take our training data and stratify them in certain ways, let's say by ethnicity, by gender, and other protected characteristics, or do we end up introducing biases into our model? So we didn't have any answers for it, but then I think that's where our conversation ended, really.
Oh, great, thank you. It's really interesting points you raised there as well, and some really well-rounded considerations. I think the point about the self-driving cars is actually really interesting, actually, there, and thinking about some of the certainly something I haven't considered in that issue, in terms of, you know, the people that would be more likely to be at risk from that, and are there biases in that? And I think that's a really interesting point. And of course, self-driving cars have come up as a something that people are quite familiar with in terms of the AI and ethics debate. And of course, that's one of the areas where you have to try and build in ethics into the AI as well, and getting the AI to make decisions. You know, famously, you have to try and build in some sort of ethics in that if the car has to make a decision about hitting you know, an elderly person or a young child, which one does it hit, and stuff like that. So all sorts of complex stuff that goes into that. So lots of ethical issues around that. Fantastic. No, thank you. A really good discussion. Okay, let's see who the final group will be today. Let's see which two groups got away with it. Oh, I think now it's going to be Saint. It looks like Saint number 5.
Okay, so we've got quite a few uses of health, AI in healthcare. So make some thoughts. We had triaging in A&E, which obviously I'll go to what can go wrong, but there's obvious things that can probably go wrong in triaging in A&E. Prioritization of patients for a particular type of treatment. Recognition of patients. So rather than having name tags around your wrist for identification, if it moved to actual identification by fingerprints or by facial recognition, or whatever, it would have, you know, potential benefits for that. So people who came to the hospital who weren't conscious, for example, there could be benefits there that they could be identified and their history known. Discharge planning was another one that we, you know, could potentially, based on certain factors, would that person, you know, it could set triggers for the person could be discharged. Potentially prevent identity fraud. So we thought about the US. So when you have to pay for your medical treatment, and potentially people trying to commit fraud by claiming either healthcare or medication by using someone else's identity. And identifying individuals for prioritization of treatments or vaccines, for example. And the things that can go wrong, so incorrectly prioritizing somebody or not prioritizing them, incorrect treatment, incorrect misdiagnoses, misunderstanding severity of an illness. So AI can detect certain things, but potentially it couldn't detect the severity of them. And potentially, over reliance on AI, where humans would detect either by experience or sensing, experience basically. And then testing of an AI model, so running testing in parallel whilst you're developing the model, and then after the event, but raising awareness of limitations. So how often things can go wrong, and maybe highlighting examples of where it has gone wrong, which in healthcare is not really what you want to do, but yeah, that's what we came up with, really.
Brilliant. No, thank you. Really good. I think, yeah, that's an interesting point about you know, highlighting where it has gone wrong. I think I mean, that's kind of the point about this session, really, is to do exactly that for you as both model builders and potentially model users, and hopefully making you better sort of critical consumers of this kind of approach as well. I think increasingly, even if you're not building this stuff, you're likely going to be exposed to this stuff. So hopefully, it's allowing you to ask the same the right kinds of questions about this kind of stuff to understand how these AIs have been trained, the kind of the understanding how it makes decisions, the data that's been used to train, the consequences of getting things wrong, testing on subsets, etc. So all really good stuff. Okay, so the last bit, I just want to last very final slide. So just kind of summarize all this really. I think we've probably demonstrated this afternoon that there's a lot that can go wrong with AI, and that's a sort of core message that I want you to bear in mind moving forward. There's a lot that can go right with AI as well, and it does have fantastic potential. We wouldn't teach it if we didn't believe that, but there is equally a lot that can go wrong, and hopefully we've demonstrated this afternoon some of the very serious consequences that can happen, and these are just a small sample of some of the things that can go wrong, the consequences that can have. So key questions really that you should be thinking about when you're building AI models. Think about, is your data set fully representative? Could your model have accidentally included biases against minority groups? How would you test for that? Can you explain your model? Can you expose enough of its thinking to build trust or expose problems that need addressing? So thinking back to the things like Shapley values that we talked about earlier, to try and get a better understanding and unpick why it's coming to certain predictions and identify, back with the skin cancer example, can we understand why it's making these decisions, and pick up that it's actually identifying images with a ruler as being problematic, and picking up on those kinds of things, and also making sure that you stop and think at all stages about what can go wrong, how could this thing go wrong, and if it does go wrong, what's going to be the consequences of that, who's going to be affected by it, in what way, and have you talked about that with the people that are going to be using this? Have you communicated that possibility and the consequences of that error? Do they fully understand that? And so I fully expect a number of you to put forward project proposals that are based around machine learning, and I think that will be great. But I would expect you to have considered some of this stuff. So when you're thinking about pitching your project proposals, think about some of these issues that we've talked about. How are you going to potentially prevent against some of that? Have you thought about what might go wrong? Have you thought about how representative your data might be, and or how you might test it? And making sure that you sort of give that sense that you've considered some of these issues that are incredibly important, because ultimately we would not take on a project where we thought there are potential there's a potential ethical minefield if you get this stuff wrong and you haven't really considered that, because that's a really important part of AI. And I said at the start, this is arguably the most important AI session, and I stand by that. Now, obviously, today we've only very much skimmed the surface of ethics and AI. Mike's included a couple of this particular link here, which you can access in your slides, and also the couple of books that we suggested at the start. So do have a look at some of this stuff. There's some great stuff here. If I go onto this website, I'll just quickly click the link through if it'll work. It's not going to, I don't think. No, it's because I pasted it as an image. That'll be right. Okay, but do have a look at that. It's all about talking about fairness and transparency in machine learning, and lots of stuff there about some of the things you ought to think about, and good practice for developing machine learning models that are fair and transparent. And that doesn't mean that you are always able to make sure that it gets everything right, because remember, there's no magical 100% accurate model. But it shows you need to, at the very least, think about what can go wrong and do as much as you can to protect against that. Okay, I'll stop there. So hopefully that's been useful for you this afternoon, and do bear these things in mind as we move through the rest of the course. So tomorrow morning we're going to be talking about machine learning in terms of showing you how to do some of this stuff. So we're going to start off tomorrow's session. We'll be looking at some of the simpler non-neural network approaches, specifically looking at logistic regression. And we'll also be looking at some of the concepts around how you might explore how good your models are. And then on Thursday session and on Thursday morning, we're going to go deeper into machine learning and have a look at neural networks and how you can build up neural networks. And in both cases, you're going to be using something known as the Titanic data set, where you're going to try and build models that try and predict who would survive the Titanic. You've also tomorrow afternoon got another session in the geographic modeling module. Remember, that's a pre-recorded session that's looking at QGIS. So do make sure that you, if you're joining for that session, you follow along with that. It's a pre-recorded video or set of videos that Kerry did last year. They're really good, but you will need to follow along. So make sure you've got QGIS installed, and there's lots of handouts. There's little handouts. You can work your way through it, and you do have the advantage that you can sort of stop as you go through it and make sure that you're catching up. But Kerry did an amazing job last year talking through that. So, and it's nice and sort of, you know, drag and drop and clicky, and there's no code, so it gives you something a bit lighter to do. But otherwise, I look forward to seeing those of you coming to the machine learning stuff tomorrow morning, when we'll show you how to do logistic regression and some of the other issues in talk about some of the other issues in machine learning. So until then, goodbye. Thank you for joining us this afternoon, and I'll see you tomorrow. Cheers, everyone.